All right, this is Calculus 5.7, and it is on the integration of inverse trig functions. So last time we covered chapter 5, we did the derivatives of inverse trig functions. So I just took a moment and rewrote them for you as a reminder. You're not going to have to use these in this section, though. So the reason why I bring it up is to remind you that although there were 6 formulas, 2 of them were identical. For example, these have the identical answer. The difference is that one was negative. Same thing for tangent and cotangent. Same thing for arcsecant and cosecant. They were the same, but one of them had a negative. So when I go to show you the rules for today for integration for inverse trig function, we're not going to have 6. We're only going to have 3. You guys learned in U sub that if you were missing something like a negative, all you had to do is put the negative on the outside. Okay? So for that reason, the left-hand side is the only one that you're going to see in your rules today. Okay? So, the only thing that you might also see a bit different is that you have an A instead of a 1. That just takes into account any other number that could exist there. And the fact that you have U prime up here, you're going to have to start setting up a chart. Now, on this chart, A squared and U squared, you're going to grab from the denominator of your question. A will always be a number and U will always be a function. Then on your own, without looking at the question, you are going to do the square root of both of those to get A and U. And then because U is a function and these questions all should have a U prime on top, you're going to solve for the U prime. Just like in U sub, if anything is missing, for example, if U prime was 2, and there's no 2 up here, you can put the 2 in as long as you put the reciprocal of 1/2 outside. Okay? So, seeing that, let's look at these questions. Okay? So, step 1 is always going to be to start your chart. So, for this problem, letter A, oops, sorry, it's so hard to see. Which of the 3, just by the setup, do you think letter A is going to be? Arcsine, arctangent, or arcsecant? Arcsine. So the way I catch that, remember A is number and U is a function. So I have a number squared minus a function squared. So I know I'm probably going to end up writing arcsine. So start your chart. Who is A squared? Good. And who is U squared? Good. Do the square root of both of those. Who is A? Good. And who is U? And then lastly, find me U prime. 1. Okay? So the only one you really have to check here is that U prime, which in this case is 1, exists in my numerator. So I'm fine here because 1 times dx is still dx. I'm not missing anything in this question. This is level easy. The moment you see you're not missing anything, all you have to do is fill out the right side of this formula here, which is the antiderivative. So all I'm going to do is write arcsine of U is x, over A is 2, and then plus C. And you're done with this one. So let's look at letter B. Visually looking at it, it doesn't have a square root, and I have a number plus a variable. Which of the 3 do you think this one's going to be? Beautiful, arctangent. So let's set up. Who's my A squared? Good. Who is my U squared? Who is my A? Square root of 2. Exactly. Don't be afraid of that radical. Be careful with this one. Who is my U? Nice. You have to square root both. So be careful not to write 9x. You have to square root the 9 as well. So it is 3x. And then what is my U prime? 3. So now is when you check to see if anything's missing. According to arctangent, I have my A squared plus U squared in the bottom. But in the numerator, my U prime should exist. Do you see my U prime existing here? No, right? So I'm missing that 3. I can put them up there. But I have to put a 1/3 on the outside. Okay? So I'm going to bring down that 1/3. Oops. And now go ahead and write the answer for arctan. Arctangent starts with a 1 over a. So 1 over square root of 2. And then arctan of u over a, 3x over square root of 2 plus c. If you'd like to, you can clean that a little bit more. But you are done with this question. All right, and letter C. So C has something more than just a radical in the bottom. It also has a function in front of it. So which of the three do you think this one is going to be? Arcsecant. Good. So let's start with our chart. Who is my a squared? Good. Who is my u squared? Okay, let's put this over a little bit. It would not be -9 because the formula has a negative in it. Does that make sense? Good question. So what would a be? Right, that was the square root of the number, so that one would be 3. And u? Not just x. It's good. You have to square root the 4 also, so 2x. All right, and then lastly, who is my u prime? 2. Okay, so be careful here. Being that this question has this function down here, there is an extra, not step, but place that you need to look. So u prime is 2, which means that there should be a 2 up here, which means I need the 1/2, right? But I also need to confirm for arcsecants that the entire u function exists down here. Do you see that from the u function and what's down there, I'm missing something? I'm missing a 2. So if I'm missing a 2 in a denominator, now I need to multiply a 2 in a numerator. Okay? Now, what ends up working out, if the same number is missing on the top and the bottom, do you see that these two 2's cancel out? Yeah. So do you see here how the formula has the u in front of the radical? That means this u that I found needs to completely exist there. There was only an x, so I need to put a 2 in, which is why 2 in a denominator requires this 2 over here in a numerator. So you can make a note to self, if the two numbers that you need to fix are one on the top, one on the bottom, the same, you do not need to do this outside. You can do it, but you see how it'll clean out? Okay, now if they're different numbers, then that's when you have to make sure you do this because this won't cross out. Okay, so now there's really nothing that I need to bring down. Now I can go ahead and just fill in my answer, which is 1 over a, which is 1 over 3, arcsecant of absolute value of u over a, which is 3. Okay? All right, so now we're moving on to this question. The last 3 questions you're going to see in this video are not necessarily going to be inverse trig functions. They could completely be something like u sub, which we've seen a lot in the past. Remember, u sub is found inside radicals too. So a lot of times when it's u sub or an inverse trig function, they can look a lot alike. Okay? Don't be afraid to go through a little bit of trial and error. So the first thing I want to point out to you, at the beginning of this chapter, I talked about a list of things to look for. One of the things to look for is that if in your numerator you have 2 things being added or subtracted, you can split them into 2 separate integrals. So for example, I can say x over this denominator, do that integral, and then plus 2 over this denominator and do that integral. At that point, it'd be solving 2 completely separate problems and just adding their answers at the end. So let's start with the rewrite, okay? I have the integral of x over that entire denominator plus the integral of 2 over the entire denominator. Okay? Now, hopefully your brain at least goes to the options of u sub or inverse trig functions because of the way it's set up. If this were an inverse trig function, because of the setup of the denominator, which of the three do you think it would be? Arc sine, right? Just because it's the a squared minus the u squared underneath the radical. So let's set up our chart. I'm going to do it over here on the side. So this could be for either of the two problems. I haven't figured this part out yet. Actually, let me come over here. I don't have much room over here. So a squared. What would a squared be in either of the situations? Good. And what would the u squared be in either of the situations? Good. Remember, the negative would be part of the formula if this was an arc sine, okay? So what is a? And what is u? Be careful. It's first you have to do the square root, which is just x. And then u prime would be 1. So that means if either of these are going to be arc sine, I need to find a 1 in the numerator, okay? Technically, 1 times anything is itself, so they both have the 1 in the numerator. And they both have something extra. What rule did we learn with having something extra? We can take it out to the front. What does that rule apply to? Numbers, variables, or both? Just numbers. So the only one I'm allowed to do that with is this one. So which of the two, left or right, do you think I'm allowed to use arc sine with? The right one, exactly. So I'm going to block this off here just so we know. We're going to approach the left one in just a minute. Let's finish the right one. I'm going to bring that 2 down. And now I know this is an arc sine. And arc sine has the word arc sine of u, which is x, over a, and then plus c. Oops, look at me. I put the a instead of the number. A was 2. Okay, so that is the answer to the right integral. Now my job is to go figure out the left one. Okay. Last chapter, I kept enforcing to you guys that when you're stuck and you don't know what to do, to always try u sub. Okay, so I know this is definitely not going to be one of the inverse trig functions, not one of the arcs, because we already tested the one that it looks like, and I had a variable that was extra. Anytime you have a variable that's extra, it's also a red flag to try u sub. Okay, so u subs, the u is always found inside parentheses or inside radicals or inside trig functions. Who would be my u for this question? 4 minus x squared. And what would my u prime be? Nice, negative 2x. You see the x up there, how I'm okay now? But I am missing the negative 2. So I put a negative 2 here and a negative 1/2 on the outside. I drop the negative 1/2, and I have the integral of u prime over, my u was only the 4 minus x squared, so I'm still stuck with that radical. Okay? And this kind of problem, I don't have a rule for a radical, so I can bring the radical up with a negative exponent. And you can write u prime or you can write du. Remember, they both mean the same thing. And at this point, I'm just doing a reverse power rule, okay? So if I add 1 to this exponent, negative 1/2 plus 1. Here, I'm doing reverse power rule. So if I add 1 to this exponent, I get positive 1/2. I drop down this negative 1/2, but remember the reverse power rule says I have to multiply by the reciprocal. Okay, and I'm not going to write a plus c here because I technically wrote it here and I'm about to bring this down. So these 2's cancel and I have negative my u is 4 minus x squared to the 1/2. Now I'm going to bring this plus sign down, and I'm going to bring this answer to the right side down. So again, you can see how we split it. We solved each individually, and then just combine the two answers at the end. All right, last two questions for today. Let's look at the one on the left. Hopefully your mind goes between an inverse trig function, which we learned in this video, or a u sub. Those are pretty much your two options. So if it were an inverse trig function, based on the setup, which one do you think it could be? Arcsecant. So let's check by setting up our chart. Who is a squared? Right, remember the negative is part of the formula, okay? So then a would be good, and then u squared, which makes u, makes it an x, good, and u prime would be 1. Very nice. So let's look back. The arcsecant formula has u prime on the top, which I'm good. I don't have any number missing. It has the entire u in front of the radical, which I'm good. I don't have anything missing. And then, of course, your u squared minus your a squared. So, believe it or not, this is an extremely easy problem with nothing missing. So I can go straight to my arcsecant formula. Arcsecant. Oops. Thank you. Sorry. I was jumping to the final answer. So arcsecant has 1 over a, which is 1 over 1, times arcsecant of absolute value of u, which in this case would be x, over a, which is 1, plus c. 1 over 1 is just 1, so I can write my final answer as arcsecant of absolute value of x plus c. All right, and for our last question, looking at the setup again, hopefully you're in between an arc trig function or a u sub. If it is one of the inverse trig functions, which one does it look like? Arcsine, right, with a function squared minus a number squared. So let's try the setup. Who is my a squared? Remember, a is a number and u is a function, so 1. And then a would also be 1. Okay, u squared would be x squared. U is, and u prime is 1. So there's a few things that should throw us off here. U prime is 1, and although I have a 1 here, I do have an extra x, and I'm not allowed to bring functions out. And arcsine would have these the other way around. Okay? So you have two signals there that let you know it is not one of the inverse trig functions. So now, what's my next thought process if it's not an inverse trig function? Good, u sub. So who would my u be? Good. My u prime, 2x. Look at what I have as my u prime, and look what I have up here. I'm missing a 2. So again, like the last question we saw that looks similar to this, having that extra variable in the numerator could also be a shortcut to make you realize that this is not an inverse trig, okay? So bring down that 1/2. And now my answer my question changes from the integral of u prime over square root of u. Because again, the only thing that changes to u is the inside of that radical. That radical stays behind. Okay? Which then I can rewrite as 1/2 times the integral of u to the negative 1/2, changing it into an exponent. And remember that u prime is the same thing as du. Okay? Antiderivative here is the reverse power rule, so I add 1 to this exponent. Adding 1 takes me to a positive 1/2. The rule says to then multiply by the reciprocal. And I also have to bring down this coefficient that was up here. Okay? I have my plus c. Those 2's cancel out. And now just replace your u with what you had identified u as. So I have x squared minus 1 to the 1/2, or you could put square root, plus c. And that's it for this question.